Welcome to the SKM Power Tools for Windows overview. My name is Johnny Ma, and today I'll be providing an overview of our Power Tools software and conduct a live hands-on presentation. I'll be going over SKM History and Background, discuss about our time-saving features, system modeling. I'll provide a software demonstration, go over other important features, and I'll conclude with some final thoughts and introduce other resources for further information. SKM has been developing power system software for 42 years now, since 1972, so we've gotten pretty good at it. SKM was formed by three young engineers, Harry Sealing, Gene Knight, and Maurice Mansour. The very first software they developed was loaded on a timeshare computer at UCLA. They called their software Dapper, which is an acronym for Distribution Analysis for Power Planning, Evaluation, and Reporting. Dapper is the foundation of our software and runs low flow, fault analysis, sizing, and much more. Dapper was later released for personal computers in the 1980s. The Capture software soon followed in 1983. Capture stands for Computer Aided Plotting for Time over Current Reporting. This is the coordination part of our software. Here is a partial timeline history of our software development, starting in the 1980s DOS days and into the 1990s, when we redeveloped from scratch for the Windows operating system. The Arc Flash evaluation is our most popular module and designed at protecting lives from electrical accidents. We are well established in the power systems industry. We have representatives in 30 different countries and have over 50,000 users worldwide. We estimate about 70% in the United States and 30% internationally. We are located in the Los Angeles area, and all sales, technical support, and software development is conducted here. Our client base includes engineering services, consultants, gas and oil, industrial process, utilities, public service, government agencies, and universities. Once you're an SKM user, you will be among the greatest companies. Here are some excellent features in the software that I'll be demonstrating later on. Hopefully I'll be able to get to all of them, but if not, you'll know that it's there for you to take advantage of when you start using our program. One thing I would like to mention is that we have the largest protective device library. By my last count, we have close to 15,000 equipment modeled. You can also easily create your own library models. Or, if you feel lazy, just email us the manufacturer datasheet and we'll model it for you. Here are some more features. Once you start to use the software, you'll realize how powerful they are and can help you be more productive. Two things I like most from this list is the custom data blocks and data visualizer. Data blocks allow you to display settings or results for every component in the one-line drawing. You can customize exactly what you want to show, and at one glance at the one-line drawing will tell you all you need to know. The data visualizer allows you to visualize or compare results across different scenarios at one glance in a spreadsheet-like manner. Again, you can customize what you want to compare. The software employs a bus concept in modeling and calculations. This concept is also used when purchasing a new software package. Basically, a bus is needed when connecting two impedance devices together. Transformers, cables, motor loads, non-motor loads are all considered impedance devices. Relay, fuses, breakers, and other protected devices are not considered impedance devices. If you are unsure which bus level you need to purchase, you can always start at a lower bus level and upgrade when you get close or exceed your bus level. There is no need to repurchase a new software package. Here is a sample one-line drawing with 30 buses. Each horizontal bar that you see is a bus. Panels, schedules, MCCs, switchboards are shown connected to the bus, but are actually the buses themselves. In addition to our most commonly used studies such as Dapper, Chapter, and arc flash evaluation, we also offer advanced studies in transient stability, harmonic analysis, reliability, and DC systems. Here is a quick overview of our harmonic analysis in action. Here we have three simple systems. The first one was no harmonic mitigation. The second system has a phase shift in the main transformer. And the third system has an additional filter. Here we can see graphically the distortion waveform for each of the three conditions. The red waveform shows the distortion with no harmonic mitigation. The white waveform shows the distortion with a transformer phase shift. And the green waveform shows the distortion with both transformer phase shift and with a filter. So you can easily see all three waveforms at the same time and do comparison. Besides seeing the results on a graph, you can also see it in a report format and also on the one-line drawing. Here is an example of an iSIM study where the one-line diagram is a typical industrial power plant. It will be used for a fast transfer switching study. Normally, the plant is connected to the utility source 1. Under emergency conditions, the plant will be switched to source 2. The effect of the fast transfer switching on the local synchronous motor will be demonstrated. The dynamic events include the tripping of the branch between bus 1 and bus 2 at 0.1 second, followed by the reclosing of the branch between bus 2 and bus 5 after 6 cycles. The branch P and Q flows from bus 2 to bus 4 are shown here. Notice that both the P and Q flows become zero after the plant is disconnected from source 1, and they regain power after the plant is connected to source 2. Besides switching studies, iSIM can also simulate all types of balanced network disturbances. This includes isolation from the utility, motor starting, tripping, and reclosing, loss of generation, loss of excitation, block governors, tie line oscillations, load rejection, load shedding, and much more. Here is a sample block diagram. The exciter, turbine generator, and power system stabilizer models in the iSIM library are user-definable. Users can create a model graphically by dragging and dropping the basic control model building blocks from the left side to the right side. Simply connect them and specify parameters for each block. We offer two types of software licensing options, a standalone and network version. You can install the software on as many computers as you want, but be allowed access to the software license that you purchase. With a green USB dongle, which is the standalone version, you simply move the hardware key around to the computer that you want to use it on. With a network license, a red USB dongle is provided, and is intended to be installed on a server that is always on. The software will then be installed on all the workstations. When a user needs to use the software will check the server and authenticate the user based on what was purchased. If the number of users have been exceeded, the software will prompt and indicate no more licenses will be available or is available. New study modules and users can be added instantly with codes that we will provide upon purchase to reprogram the USB dongle. There is no need for us to ship another key or software. For read-only access, you can use our PTW Viewer software instead. This will allow an engineer to view and interact with all the one-line drawings, TCCs, reports, arc flash labels, and so on. This is great for technicians in the field that will be setting up the equipment and won't need to run any calculations. Okay, now let's do a live hands-on demonstration of the program. What we have here is the software interface. We have the toolbars at the top. I will start by opening or creating a new project. Once a new project is created, I am presented with a blank one-line drawing. Next to it is a component editor. I will start by placing buses on the one-line drawing. As I place a bus on the drawing, the component editor is populated with those components. I'll insert a utility, a transformer, a cable or feeder, an induction motor, and a non-motor load. Ways to navigate the one line includes panning. Panning can be accomplished by holding down the mouse wheel and moving the mouse. Zooming can be accomplished by moving the mouse wheel up and down. Okay. I'll start by entering the voltages for every bus. Simply double-click . Okay. Notice bus 3 is automatically populated with the system voltage of 480. Software knows that the bus voltage here must be the same as the bus voltage on bus 2. I'll enter 300 MVA for the three-phase contribution, 100 MVA for the single line to ground or the line to ground value. For the transformer, I'll enter 100 or 1000 kVA. Actually, I'll pick something from the library. Here is the transformer library. I'll select the first drive type. Okay. Notice the transformer impedance is taken from the library and grayed out. I'll move to the cable. Again, I'll click on the library button. Now I can see the list of all the cables that we have in the library. I'm going to select a IEEE 141 Redbook cable, NEC table 13 or 310-16. Okay, cable size 2/0, 2 conductors in parallel at 100 feet. Okay, impedances are taken from the library. Let's move on to the induction motor. Let's specify this as 100 horsepower. And for the non-motor load, 100 kVA. For this simple system, all the input data is complete. Since it is now complete, we can start running our analysis. I will start by running a load flow and short circuit analysis. Okay. 0 fatal errors, 0 warnings. Okay. Once we have that complete, we are now ready to look at the report. Simply click on the report button on the toolbar, text report, and let's look at the SC report. Here we can see the results for each bus in the system. Bus 1, bus 2. In addition to looking at the results on the report, we can look at the reports using data blocks. Okay. Just for comparison purposes, the initial RMS three-phase value, short circuit value, is 20,477 amps, which matches exactly the value in the report. We also have CRIS reports. CRIS report presents the results in a nicer formatted view. Okay. We have other data blocks formats available. You can also customize the data blocks that you want. Okay. Let's look at the load flow power data. Okay. This is the results from the load flow study. Another advantage of the data block is that it is dynamic. For example, if I change the motor from running to starting and rerun the study, the load flow voltage drop changed to 4.74%. Previously, it was at 1.37%. So as I make changes to my system and rerun the study, the data block will update automatically. Now let's look at the capture part of our program. I'll start by inserting a relay and a breaker. I will double click on the relay and go to the library. If you notice, our protection library is very comprehensive. We have manufacturers from Basler, Cutler Hammer, GE, Multilin, SEL, Siemens, Square D, Westinghouse, and this is only the electronic part of the relays. For the relay in this example, I'll select a Basler BE1 951. I double click and it is assigned to this relay model. For the breaker, go to the library. Here we have the static trip breaker library. As you can see, we have many different models from many different manufacturers. For this example, I'll pick an ABB breaker. MPS 5. Okay. To create a TCC drawing, simply highlight the portion of your system that you want to create a TCC drawing for. Once that's complete, simply right-click, go to TCC drawing. Let's give it a new name. Say yes. Here is a one-line drawing, the portion that you selected on the left-hand side, and the TCC drawing on the right-hand side of all your components. The TCC drawing is pretty dynamic. You can adjust the curve by simply dragging on the graph and dropping. Dragging and dropping. As you do this, the settings of the relay changes. Okay. Again, for the breaker, settings are updated automatically as you make changes to the curve. Data blocks are also available on the TCC drawing. Again, to enable data blocks, go to the Run menu, Data Block Format, select TCC settings or create another one if you desire, and click on Apply. Once you're happy with your TCC drawing, you can present this information to your customer in a nicely formatted view. Here I will select a TCC one-line 8.5 by 11 landscape format. And there you go. Now let's move on to ArcFlash evaluation. To run ArcFlash, simply click on the Run menu and go to ArcFlash evaluation. Okay, here is the ArcFlash options. Once you're happy with your settings, click on OK. And just like that, ArcFlash results are calculated and displayed for every bus in your system. Okay. ArcFlash results are also dynamic and based on the protected device settings in your system, meaning if I change relay settings or breaker settings, ArcFlash should automatically update. For example, if I move this relay up and down, you notice the result, the instant energy result for bus 2 changes to 60 cals per centimeter squared. By moving it back down and the device clears fault faster, the ArcFlash level reduces significantly. Okay. Once you have completed your arc flash hazard analysis, you can generate labels for your equipment. To do so, just click on this custom label button. We have example labels that you can pick from. If you want to make any changes or modifications to the labels or create your own, simply click on the designer button. Here you can change the page size, the label size, orientation, margins. For the content of the label, click on here. You can see all the different fields available. We also have a keyword table. This allows you to translate the labels in a different language. If you're doing a study for a customer in Mexico, you can change dangerous to a Spanish equivalent word, and it will be reflected on the label. Okay. We also have work permits. This is used by electrical workers when they plan to work on energized equipment and require manager or supervisor sign-off before they conduct electrical or energized work. Okay. Now I'll just demonstrate some functionalities in the program that will help you be more productive. I'll create a new one-line drawing. In the software, you can have multiple one-line drawings with the same component. For example, I'll copy this section on the first drawing and paste it to a brand new drawing. Okay. We also have an expand feature where you can expand equipment or components and see what's connected to it. Notice now the same equivalent as the first drawing. If you don't want to see this, you can simply highlight and remove or hide it. Okay. I'll plot this breaker on a TCC drawing. Notice how as I move the curve on one drawing, it gets reflected on the second TCC drawing. So although the same component exists in different drawings, whatever changes you make to them will be automatically updated in the database. Here, we also have a clone feature. If there are portions of your system that are replicated throughout your entire system, you can clone it instead of remodeling identical parts of your system. We also have a feature called templates. Templates allow you to create a template of a portion of your system and allow it to be used for any other projects, not just the project that you're in. Okay, so once you want to paste a template, simply go to the one-line menu, Templates, select the one that you created, and just click on Paste. In addition to copying the components, data is also copied over. If your system is very large and you want to try looking for something in the drawing, we have a Find in One Line feature. Simply find the component that you're looking for and click on OK. And the software will jump to it and also highlight it. The software has a query function. This allows you to create a query, customized query, or use one that we created. For example, if you want to query all loads, simply click on this one and click on Run. It will highlight all the loads in your drawing. The software also has a link feature. This link feature allows you to link to other drawings or TCC reports or an external document. An example here is if I want to place an additional link for a breaker that I have to show manufacturer information. If I double click on this link, it will open up the manufacturer data sheet. We also have equipment evaluation. This allows you to evaluate all your components in your system. It will evaluate your rated information against the calculated short circuit, low flow information or results. It will tell you if it passes, or if it fails, or if it's marginal. Okay. Here are the criteria to set whether a equipment will be marginal or fail. The evaluation criteria, what you want to evaluate, and input data criteria. Here we can see there are two transformers that failed. The reason for failing is displayed on the bottom. For the transformer, the bus low flow voltage is different from the device rated voltage for more than 10%. Okay. That information can also be displayed on the one-line drawing. Here, as I click on this button on the toolbar, it will show the equipment that failed in red color. The software also has a feature called Scenario Manager that allows you to evaluate different scenarios of your project and look at different configurations. Here I have a sample system that we use for demonstrating different scenarios for arc flash purposes. I created 4 different scenarios. Scenario 1 has a maximum fault in open tie. Scenario 2 has a maximum fault with a closed tie. Scenario 3 has the minimum fault condition with an open tie. And the last scenario has the minimum fault condition with a closed tie. I'll go through each one and show you the changes that I made. For this scenario, maximum fault in open tie, the utility is set at 1.02 per unit, and the tiebreaker is open. For scenario 2, again, the utility is at maximum fault at 1.02 per unit. However, the tiebreaker is now closed. The third scenario, the utility has a minimum fault of 0.98 per unit with an open tiebreaker. The last scenario has the minimum fault with a closed tiebreaker. Okay. I can run arc flash. There is a scenarios button up here that allows me to look at the results for the worst case scenario, comparing all 4 scenarios I selected here. When I click on OK, it will go through all scenarios and display the results from the worst case scenario. In the summary view, I can see that for bus 1, this result came from scenario S4. S4 refers to the minimum fault closed tie condition. I can also see this result on the one-line drawing. Results are shown of the worst case for every bus. I can also make use of the data visualizer and show me the results in a spreadsheet-like manner. Here on the header, this is the maximum fault open tie condition, maximum fault closed tie, minimum fault open tie, minimum fault closed tie. And this is a column that shows the maximum value across all the scenarios. If I check these boxes, you will highlight the scenarios that have the maximum value, or the minimum value, or none, and additional comments. Not only can this be used for arc flash, this can also be used for short circuit, load flow, or any other analysis. Okay, so now this concludes the demonstration part of the presentation. Here are some final thoughts. The software is integrated yet modular, where you only need to purchase what you need. The SKM software is extremely fast and flexible. The software has hundreds of advanced features, including transistability, unbalanced conditions, low flow, integrated arc flash evaluation, and DC systems analysis. SKM software is used by the leading equipment manufacturers for system studies, and SKM is known for high-quality software and outstanding technical support. We include all of our reference manuals on our software CD and more on our website. If you need further technical support, you can call us and ask for our support department. If you want to take one of our classes that's hosted throughout the United States and Canada, you can go to skm.com and click on Training. Our calendar and schedule of classes are listed there. If you want training for more than 5 engineers, it may be more worthwhile to schedule one of our engineers to conduct the class at your offices. You will save on hotel costs and other travel-related expenses. Thank you for your time. If there are any questions, just email us at sales@skm.com. We'll be more than happy to answer any questions that you may have.